Hello everyone, welcome again to another tutorial in NPR Maya, your channel to learn how to generate NPR shaders in Maya software. In today's tutorial, we are going to start working with the hypershade and learn, in general terms, how nodes work. This will allow you to get an understanding of the hypershade and learn how to generate what are called procedural shadings. So, let's get started. Maybe you have already been fiddling with the hypershade window before and you know what it is. But for those who don't know about this window in Maya, the hypershade is the central working area of Maya rendering, where we can build shading networks by connecting render nodes. To access the hypershade, we need to click this icon on the shelf. As we can see, the hypershade window is divided in different parts. As a default, we have the browser, where we can find materials, cameras, or lights that exist in the scene. We can also have the viewport to see the scene. We find as well the material viewer, that displays the material we are working with. Then we have the create window, where we can find the list of all the nodes that exist in Maya, Arnold, or any plugin we have installed. In the center, we find the hypershade node area or node editor, where you can create shading networks, which are basically webs of interconnected nodes. And finally, we have the property editor, where we can edit the attributes of each node. If you cannot find some of these windows, you can go to the Window tab and find here the window you are missing, or add some extra ones. Once we have seen a brief introduction of the hypershade window, I will show you what type of nodes we can find and how they are generally connected. To do so, I'm going to make an outline of how a shading network is formed, and afterwards I will show it in Maya. When we create a shading network, the connection goes from upstream to downstream. That means from left to right. The shading network usually starts with a texture node, which basically add details to materials. Textures, which come in gray color, are accompanied by what are called texture coordinates, which determine how and where the texture needs to be applied on the surface. Some of the adjustments we can do are repeating, tiling, or adding some noise. After the texture, we will usually put a material, which is also shown in gray, and they basically define how surfaces react to light. Materials are usually accompanied by what are called shading groups, which is the last element we usually find at the end of a shading network. The shading group nodes have blue color, and they are responsible for making sure that all that have been done upstream, so here on the left side, is applied to the surface. Now that we know what the structure of a shading network is, let's see where we can find each type of node. If we check on the Create window, we can find textures, for instance, under the name of 2D texture. Let's select the ramp. Now we see that we have two nodes in the node editor that are connected. We have a texture coordinate node, which are in purple color, and a texture node, which are in gray color. If we return to the Create window, we can find materials under the name of surface. Let's select an AI standard surface. As we see, this material contains the material node, which is connected to a shading group node. I'm going to mention another type of node that we can find, which is going to be very useful for making adjustments in our shading networks. This type of node is called utility node and allows you to add extra effects to your shaders. If we go to Create window and press Utility on the Arnold tab, we can see that there is a wide variety of them. Now that we have roughly seen the types of node needed to create a procedural shading, let's take a quick look at what the ports on the nodes are and how we can connect them. If we see the nodes, we notice they have some dots on their sides, which are called ports. And here is where we can connect some nodes with others. They come in different colors, but for now I will explain you two of them, which are the red and the green ports. The red color indicates that it is a parameter with more than one value. If you look next to the parameter name, you will see a small plus. If we click on it, it will display all the values inside. This can be UV, RGB for color, or XYZ, which is for position. Sometimes XYZ can work as a RGB as well. In some occasions, we can find some of these ports in green color, as we see in the texture, but they work in the same way. However, if we click on the plus and we want, for example, to connect just the red color directly to the base color, we cannot do it, because red color is a single value. To do that, we can either connect it with the base port or press the plus on the base color and connect it with the red, green or blue color. Then, if we click on the out color port, we can connect it, for instance, with the base color or a specular color port. However, we will see some parameters turn gray, indicating that they are not possible to connect with each other. The other color we have is green. That means just a single value can be connected. For example, if we take the out alpha port from the texture ramp, we can connect it to the base port. And just like before, the values that we cannot connect with the out alpha port turn gray. And that is all for now with this tutorial. In the next video, I will show you how to create and apply a texture in the hypershade. I hope you found useful this tutorial, and I will see you in the next one.